So what we're going to do is run through recommendations, short discussion of what we've been doing so far. And basically what we want to do this time, for the first time in many, many years, discuss a revision to the recommendations. The reason being not that there is any significant change to the content. That stays pretty much unchanged. But from the questions that we've heard from the adopters and the kind of interpretations that they had, we thought we might want to clarify a few of the recommendations and phrase them slightly differently and also more explicitly in terms of real recommendations on what you must do and what you should do and so on. So what I spent most of the time on is discussing this revision of the recommendations, getting your feedback also from online. If there is any comments online, just shout out and I'll try to keep a watch on the online screen as well. So we'll go through that. And then any further adoptions. Good, so next slide. That's the maintenance meeting again, but this time it's for the first time that we actually go through a revision. So who hasn't been, as you've all been to data citation working group meetings before, is it? No? No? Okay. So in this case, what I'll do is I'll very briefly go through the history of the working group and actually explain what we set off to do a couple of years ago. Go very quickly through the recommendations in a non-structured way, just getting the gist, and then we'll go into the details. So next slide, please. When we founded the working group, there was basically two problems that we were trying to address when it comes to, and initially the focus was really on data citation. We wanted to make data citable, and there was two issues that we saw. If you wanted to assign a citation, a PID to a data set, that data set would need to be static. So it needs to be a file, a zip file, a CSV file. If you wanted to basically assign a citation to a data set that's evolving, you could point to the evolving source, but then you couldn't go back to exactly the same data set that you wanted. So if you have a data set where new measurements are coming in, or where new files are being added, or new images are being added, and you have a citation, then you either do a zip file, cite that one, and then you have to provide that, download it, and use it. And if there's whatever, an error being corrected, or new files being added, you needed to create a new zip file and get a new, whatever, persistent identifier assigned to it, which is not terribly scalable if you have large volume data and you store it in multiple dumps. And the other disadvantage was that you could only provide zip files every now and then. So whatever, a monthly update, a quarterly update, an annual update, but anything that comes in between, you couldn't use for reproducible research until the next freeze point was being reached. Okay, so that's the problem with dealing with dynamic data. So what we wanted to have is a mechanism to identify data precisely at the state as it was at any given point in time. So if you have a sensor data stream coming in that's sending data in by the milliseconds, and at a certain point you access the data and want to do a study on that, you want to make that state of the data set citable and not having to wait for the next quarterly release. Next slide, please. The other thing that we wanted to address was that you hardly ever cite an entire database. So if you've got whatever sensor measurements are coming in from a range of sensors, air quality measurements or water quality measurements, and you have a number of measurement stations distributed, and you're collecting data over a long period of time, for any specific analysis and study, you wouldn't always download the entire database and use the entire database for a study, but you use a subset for it. Certain number of measurement stations, certain channels, certain time frames that you would be using for the analysis. And if you wanted to provide a citation for that subset, the only way you could do is you could point to the data source and then provide a natural language description saying, okay, from this data source, we selected the 50 measurement stations in that region, and we selected the alpha and beta channels, whatever, and we downloaded the data from the 5th of January till the 25th of March. That would usually what would go into the method section of a paper. And then we would describe that's how we selected it, and this resulted in 50,225 records. Now, anybody who would try to recreate exactly the same data set would need to recreate exactly the same query, hopefully arriving at exactly the same number of records. And that's actually quite challenging because natural language is usually not terribly precise. So if you give a from to time frame, it's not really clear whether that includes or excludes the 25th of March, for example, so open or closed intervals. And that's the other thing that we wanted to get around with. So providing a citation for any arbitrary subset of a potentially huge database, can be a single record, can be the entire database, can be any arbitrary subset, rows, columns, regions in the images, whatever you wanted to do. Next slide, please. So that's why we founded the working group, and it was active from March 2014 till September 2015. And we presented then the final version of the recommendations at P7 in Paris. So it's one of the very, very early working groups that we were running. And then we asked for endorsement only at the next plenary, basically, because we wanted to go for real implementation. So we had the recommendations out, but it's easy to put something on paper. We wanted to see whether it actually works and what the impact on infrastructures is, because it's ultimately the data infrastructures that would need to implement the recommendations. And so then at P8, it was finally endorsed. And since then, all that we've been doing basically continuously is help data centers implement the recommendations, answering the questions, helping them with guidance and examples. Next slide, please. So what is the solution that we recommended? So what we have usually is data. And when I say data, it can be anything. It can be rows and columns in a relational database or CSV files. It can be a file systems with thousands of files. It can be multidimensional data cubes, such as netcdf files. It can be a video stream, can be audio streams, can be maps that are scanned. So any kind of data. And we have a means to access that data. So we can select rows and columns in a database. We can select files by file name or properties in a file system. We can select regions on an image by bounding boxes or by drawing a delineating boundary or by selecting certain parts of the color spectrum. We can identify segments in videos by start and end points. Graph databases, you can identify subgraphs with Sparkle queries. So whatever means of accessing the data, let's call that a query for the time being. A query language can be Python code, can be SQL, Sparkle, anything that you want. So we have data and we have query. What we want to make is we want to make this dynamically evolving data precisely identifiable and citable. And we do that via the queries. Next slide, please. So what we need to do, and this is the key point of the recommendations, if data is changing, new data being added or erroneous data being corrected, deleted, and you want to reproduce earlier states of the data, you need to make sure that the earlier states are still available. Okay? So that means that the data needs to be versioned and timestamped. Versioning basically means whenever you insert new records, you insert them with a timestamp when they become available. When you correct an error, you don't overwrite the old value, but you mark the old value as deleted with a certain timestamp and insert the real value, the corrected one, with a new timestamp. And if you just keep adding data, you add it with the timestamp when it arrives. And if you delete something, you mark it as deleted. So you have this data versioned, and you have a history with timestamps. If now a researcher wants to select a subset of that versioned data for a specific study, they pose a query via some form of query interface. They draw bounding boxes, select filter statements, and Sparkle queries via APIs, whichever way. What we do is, what we recommend to do, is to store that query string with, and I simplify now, with the execution timestamp. Okay? So you have a timestamped and versioned data source. You have a timestamped query. And that means at any point in time in the future, you can rerun the timestamped query against the timestamped and versioned data source to recreate exactly the same subset of data. And all that you have is a storage overhead, apart from versioning the data, which is something you need to do anyway if you want to go back to your list, is storing the query string or the execution statement for the query string. And that's kind of the nutshell of the recommendations. There's a few other magic things that we do, such as computing fixity information so that you can identify whether the query worked out, adding some metadata and so on, and that leads to a landing page. But that's basically the core. Timestamping and versioning the data source, no matter whether it's a file system, a database, a graph database, and a video stream archive, and so on. And storing the query that you use for accessing it. Next slide, please. The nice thing about this is that for the researcher, nothing changes. The researchers can still select the data that they want to use using whichever mechanism they use. All the effort is actually, and that's nice from the researcher's perspective, is on the data infrastructure side. The data infrastructure takes care of timestamping and versioning. The data infrastructure takes care of storing the query string. All that the researcher gets is the data and a persistent identifier. The fact that this persistent identifier points to a query is also transparent to the researcher. They may know about it, but you may decide not to reveal that. It's just that when you click on it, you should be able to get exactly the same data back. Yeah? So that's the one thing. No changes for the researcher. It's a service that the infrastructures can provide. The other thing that is nice is that the PID, next tab, please. That the query string also provides precise metadata of what subset of the data source the researcher has selected. So no matter what the researcher types in the method section of the paper, what they thought they selected, the query string is a precise description of the subset. It's the precise coordinates of a bounding box. It's a SPARQL statement for a subgraph. And that comes automatically and for free. And we are now actually looking also at mechanisms of transforming that structured language of a query into a natural language description that you can put in the method section to make sure that this is correct, because you can use pattern-based. You don't even need AI to do that. You know? So you can transform that into a reasonable natural language description. The other thing that you can do, next click a bit, please, is that having the query string, you can not only recreate the data set as it was at the time of execution, but you can rerun the same query with the current timestamp and thus get a semantically identically subset of data, but benefiting from all additions and corrections that have happened since. So all errors that have been corrected in the data set, you can get exactly the same subset semantically, but benefiting from those corrections. Again, something that you cannot do in the old traditional approach where you run a query, you extract the data, zip it, and upload the zip file elsewhere. Yeah, so this is the other benefit, apart from the storage overhead that you get with this way. And last but not least, next click, please. Having the query store allows you very nicely to analyze which subparts of the data archive are actually being accessed and used, which is valuable information for the data infrastructure in terms of usage tracking and storage optimization. Thank you. Next slide, please. So these were the recommendations that we came up with originally, and we had a nice 2-page flyer where they were very concisely summarized. It was basically you need to do data versioning, timestamp, you need to set up a query store, and then a few of the more confusing things, such as checking whether the query is semantically unique so that you avoid assigning 2 different PIDs to something that's identical. We discussed how you can sort the results, because for some processes, the data needs to be in a consistent sorting. We had fixity information for the result verification. We discussed different approaches to query timestamping. We discussed assigning a query PID. Then we said, you have to store the query and you should provide citation text. So that's the preparation. That's what happens when researchers interact with the data repository. When you resolve a PID, it needs to lead to a landing page, and that landing page should be machine actionable. And important thing, no data infrastructure remains unchanged forever. So at some point in time, very likely you need to migrate your data representation to a new database, completely different storage format. We have recommendations on what to do on technology migration. And then we were basically done. We had 13 recommendations, and somebody in the audience said, that's an unlucky number. So we added a 14th recommendation, say, if you do changes to the infrastructure, make sure that this works out correctly. Do a verification step. Yes, please. What do you mean that it is transparent? Yes, but so you pose a query that returns a data set, and you want to cite that data set so that some other researcher can use exactly the same subset of data. Then Yeah. So, okay. So you want to store the query at the user side, not at the infrastructure side. Yes, that was a proposal. That does not work because of this issue here. If the infrastructure ever changes its data representation, then you need to migrate the queries. So you know, if there's hundreds of researchers using an infrastructure distributed around the globe and they have the queries locally, how would they be informed that the infrastructure is changing, and how would they migrate the queries? Um, could be done, but then the infrastructure would need to trace back all the changes, which is extremely hard. No, you migrate it once and you can forget the old representation. Okay. So we had a long discussion about it, but so the recommendation is the queries should stay with the infrastructure, because it's also the infrastructure that has the local timestamp. So we were also discussing distributed repositories, where we had one use case where they implemented it across a federation, and then each local instance would have its local timestamp, store the query locally, and centrally it would keep basically track of which results were returned. So yeah, so that's basically makes it more compact, and that was the recommendation from the repositories that we were discussing with. It's not the only solution. I agree with that. You can do other ways around, but that's the recommendation around it. Good. So that's the old version. And these are, yes, that's fine. These are the ones that we are now revising. Nothing changes in the content, basically, but some of the phrasing was, as we have to admit afterwards, a bit awkward, not clearly specified as recommendations. So we are now going through these and change them. But before going into the revisions, next slide, please. Just a bit of look back. So what we have, and that's basically what's still valid, we have this 2-page flyer with a front side and a back side that very briefly summarizes the recommendations. We have, at the time when we published this, a somewhat more detailed report that provides a bit the thinking behind it, where we try to explain why we came to a certain recommendation. That's a, I don't know, 6-7-page document. Then we had a number of infrastructures that were implementing the recommendations. And we have implementations for Git repositories, for CSV files, for relational databases, quite a lot. We had one for netcdf files. We had one for XML repositories that were distributed. So a lot of different infrastructures that were implementing it. And there is a number of adopters reports and webinars available on that. And the one thing that we're really proud of is this last document down here. Something that was published in 2021 in the Harvard Data Science Review. Basically a summary of all the implementations that we had, from demo use cases to real-life deployments in large infrastructures. And we think this was the one thing that got us really excited and happy. And it also shows how long it takes for a recommendation that came out in 2014, 15, basically, to actually grab hold and be deployed in real practice. Next slide, please. So that's what we call our Opus Magnum open access available. If you want to take a look at it, if you're considering implementing it yourself, I'm sure you will find that one of the use cases that are similar to your setting, and that you can then use either to contact the use case owners or find the lessons learned. But as I said, as a working group, we're also happy to help infrastructures implement these solutions. Next slide. By now, these recommendations have been picked up by a number of bodies that are recommending them, or at least pointing to them. ECIP, Data Citation Guidelines for Earth Science, is pointing to it. ISO 690 is pointing to, that's the guidelines for bibliometric citations. There has been some effort to get it into a EC standard, which has not been moving ahead because the EC is not issuing those standards anymore. So that's still on hold, not because it has been rejected, but because no new standards have been released. Then we have a number of reference implementation for MySQL and Postgres, for CSV files, XML, for a CCAN data repository, and Sparkle. And I just noticed that the new PowerPoint template is awful to read with this dark thing. I have no clue. Yeah, should have sticked with the very old one that we were using all the time. The P's in the brackets, P8, P12, points to the plenaries, where you find the coding presentation in the slide deck. So all the plenary slides presentations are still online in our working group. So if you're looking for whatever the XML, go to plenary 5 and you'll find the slide deck that presents these. Next slide, please. Then we had a number of early pilot implementations. These have never been put into practice, really, into operations. Those are demonstrators where we tested them on different settings for different types of resources. So, linguistic resources, the Argo Global Array, it's not rolled out in the Argo Global Array, but they were testing it and seeing how it could be implemented. And I would need to get back to them and see how far they have progressed in actually implementing. For us, it was really important. Does it work? Does it work for really, as we claim, for any kind of data and any kind of query construction language in the background? Next one, and that's the real deployment. So the CBMI was the first one, the Biomedical Center for Informatics at Washington University, Vermont Monitoring Cooperative, Climate Change Center Austria rolled it out operationally, EODC rolled it out operationally. The biggest implementation is Ocean Networks Canada. They have very early started testing it in their existing infrastructure, and then they went on to re-implement the entire infrastructure. And when they set it up from scratch again, basically, they have incorporated those recommendations in all data sources that they were capturing. So from the videos and audios that they're recording on the seabed to the measurements from underwater stations, from the ships that are cruising the channel. So really a very impressive realization. And going beyond, so they, for example, have also automatic descriptions of the data being generated from the subset selected. So that's the presentation at P21. DBRepo is one of the more recent ones in a relational database repository, private cloud hosted one that is also implementing them. And what we are taking a look now is new types of data, such as online learning AI models, where the AI model is continuously changing. And you also want to refer to the AI model at any given point in time, which might be relevant for operational issues if you want to track back the state in terms of traceability, accountability for decision making. And we have a first demo implementation of that one. And also for versioning ontologies, because ontologies are used in so many settings, pointing to an external source, ignoring the fact that that source might change its definition at any point in time, which has impact on my data. And so we think that any ontology that's used for research purposes must be versioned and traceable back over time. Next slide, please. So that's the recommendations as they stand in a nutshell. Is that reasonably clear? Yes, questions, please. Mm-hmm. Yeah. Mm-hmm. Yeah. Mm-hmm. Exactly. Mm-hmm. Mm-hmm. So the very first deployed use case, just a second. Okay. Yeah. Yeah. So the question was basically how to implement it in medical records management, basically where data comes in continuously. Exactly. Yeah. So that was actually the first production deployed use case that we have, CBMI. And basically what you do is for the records, which is structured data, so likely a relational database, you can basically use temporal tables, which are SQL standard since SQL 2012, which automatically do the versioning and timestamping, or you can manually add the edit record and deleted record timestamp to every record that is being added into the database. And then the resolution of the subset selection is simply storing the SQL query. And these types of structured data are actually the most prevalent ones. That's the ones that we've seen most adoption in, because structured data is such a widespread use. And DBRepo, for example, which is a private cloud-hosted database repository for research data, open source one, that implements it natively. And that's actually how we try to convince researchers to use such central infrastructures rather than their own homegrown database under the desk of the PhD student, because that way all the data management is centralized. Somebody takes care of security and patches, and they don't need to worry about versioning and timestamping. It's happening automatically. And what you might also find is what we had in this case when we were discussing with, I guess it was this use case, it might have been a different one, where it was a different use case, where we also had the issue where we were discussing this timestamping and versioning. And then the research group said, this might be difficult to realize because it's a lot of overhead. And so we met with the tech people who were running the database and we were explaining the approach. And the tech people said, we are doing the timestamping and versioning already anyway. We just never told anybody because we thought nobody would be interested. For us, it was just a safe fallback mechanism to avoid any data being deleted or overwritten. So that's actually almost the simplest case to implement it. I agree. But basically, in my perspective, that's the big difference between a research data infrastructure and a data infrastructure. So anybody can host data and override the data and delete the data, but research is about reproducibility, about traceability. And so this is one of the key requirements, because if the data is overwritten, no way you can ever reproduce anything. And if you can't reproduce it in many disciplines, that's not considered proper science anymore. And so I guess this is a step. And this is a step that we have to take. I mean, we're not saying, and it's not trivial. We are aware of that, but I think it's a necessary evolution. And in many cases, it's actually easier than the infrastructure thing. There is edge cases where it's massively complex. So if you have updates in the millisecond and overriding in the milliseconds, but even those, we didn't have a use case where we couldn't apply it. Graph databases are challenging how to do it with Sparkle Star and stuff. So it's not trivial, I agree, for some settings, but I think it's a process that we need to go in. There's not a 0 and 100 thing. Getting it. I think anything is better than storing zip files of weekly, monthly, or annual exports. That's not where we want to be. And so it's a step-by-step process. Fully agree with that. But I think it's also a good point in saying what is us as research infrastructures as opposed to a commercial infrastructure that just simply spins out data and makes it available. Any further questions? I'm just taking a look online where there's anything, but I don't see anything in the chat here. So if there's no questions online, then we continue. So revision, those recommendations have been standing pretty stable for the past few years. As I said, no changes to the core of the recommendations, but we rephrase them, we rearrange them, we bundle them a bit differently. And we start, for example, and there is a slide on that, starting with the title, because the title in the working group was called Dynamic Data Citation. And that created a lot of expectations that we were not wanting to address. So as you notice, we were discussing how to identify precisely the subset of data that was being used in a study, how you cite this in the sense of which phrases to put in the bibliography, how to assign credits to the contributors to the data, and so on and so forth. These are things that we don't want to discuss in this working group. And so the term data citation was a bit misleading. And so also for the summary paper that we wrote, the title was already precisely identifying arbitrary subsets of dynamic data. And we stop at the point where you assign a PID that takes you to a landing page that allows you to get that data and, of course, descriptive metadata. Credit giving and all of that is beyond the scope. So we rephrased the title. The recommendations were phrased pretty sloppily. We recommend to do A, B, C, D, E, F, G. 1 to 14, actually. Now we phrase them a bit more precisely as must and you should. And we try to explain why most of the recommendations are must criteria. And we try to explain why one should do something, but it's okay if it's too difficult to implement for a specific setting. And we also merged a few recommendations so that we get down to a smaller number. Now we're down to a dozen, which is 12 recommendations to make us happy. Next slide, please. So as an overview, recommendation 1 now will combine the timestamping and the versioning. So that's a merger from recommendation 1 and 2, because those two go together and you can't do them separately. And the query store then was the former R3. We have a new recommendation that is on limiting the query functionality. And this was something that we had implicitly in the recommendations, but we wanted to make it explicit, because what we wanted to stress is if we want to ensure that a query can be re-executed 5 years from now, 10 years from now, we should only use query constructs that can be guaranteed to be re-executed identically. So select project bounding boxes and all pixels that are smaller and equal than the bounding box, that's static. That's something you can guarantee recomputation of. If you do the calculation of a mean, an average, that depends already on the sorting, and you might lead to numerical inaccuracies. And the more complex computations might depend, if you compute a Fourier transform as part of the data selection, then it's pretty hard to guarantee identical computation 10, 15 years in the future. And so we recommend that one should limit the query functionality to really selecting the data and doing the processing as a separate step. Again, that will be a should. And we had it in there before, but now we put this as a dedicated recommendation. We have the other ones unchanged, just changing the enumeration, query PID, query timestamping, consistent sorting, which was called stable sorting in the past, and stable didn't mean anything. So consistency is the thing that we focus on now. Result set verification, query persistence is there, and the citation text. Next slide. The landing page is now a single recommendation. This was recommendation 11 and 12. You should lead to a landing page. And in the old days, we had that it should also be machine actionable. Now we combined it into one recommendation. It should lead to a landing page that's for humans and for machines, which is by now accepted standard. And then something that we also had explicit and now is a new recommendations, a research infrastructure must also provide the functionality to actually re-execute the query, because just storing it doesn't help. That was implicit. We thought it might be smart to make it explicit. And then we have one recommendation 12 on technology migration, which addresses then also the migration of the coding queries. So that's a run through very quickly. Recommendation 14 has been deleted. Verifying whether you did everything correctly should be inherent when you do the migration. Next slide. So what I want to do now is I want to go block by block through the recommendation text. That's a document that you find linked from the working group page or from the session page. And I would like you to shout out if there is anything in the phrasing that you find confusing, wrong, misleading, anything that you disagree with, or anything that you think might lead to concerns. Okay? So I'll go through the recommendations by step. The first thing that we do is changing the title. Precise, actionable reference to dynamic data, and then recommendations of the working group on data citation. That's the new title. Really focusing the precise and actionable reference to dynamic data, which obviously also includes static data, because static data is dynamic data that has 0 updates. Okay? So for any kind of data. And that's the version that we had with the last edits on the 9th of November. So no more citation, focusing on referencing and identification. And we might discuss whether we want to remove the dynamic, because it should work for any kind of data. But we still think we should keep it in there because it stresses an important aspect of where you actually need that kind of solution. CSV files are trivial if they're small and static. Point to go. Next slide. Structure of the document, we give the purpose, some background and context. Then the key part is, of course, the recommendations. Then we have a section on benefits. Then we also, this is new, we explicitly discuss not endorsed aspects, not endorsed approaches to say why. So for example, semantic versioning is something that we discourage as version 1, 1.1, 1.2, and we'll get to an explanation of why that is, and why we recommend using the query-based versioning and then having the semantics as an assertion to the query. So saying the query at the 15th of March is a stable version, that's a stable release after some error checking or whatever. So you can use semantic versioning by ascribing semantics to a subset, but the identification should not be a zip file of version 1.1. And also because of some discussion on major and minor releases. So that's something that we discuss here. Then we list briefly current adopters. We highlight the most frequent asked questions, and then maintenance plan. Next slide, please. Yep. Yep. Can we go back? Executive summary. Yeah, so it's kind of in the purpose, but we can provide that. Yep. 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 Sure. Yep. No, and we also will try to get these into a 2-page document again. That is kind of an executive summary. Good. Yep. But I'll take the down separate. So purpose. These recommendations, and this is now quoted verbatim from the document. These recommendations enable researchers and data infrastructures to identify and cite the precise data used in experiments and studies. Instead of providing static data exports or textual descriptions of data subsets, the recommendations support a dynamic, query-centric view of data sets. They enable unambiguous identification of the precise subset and version of data used, supporting reproducibility of processes, that should be a plural here, and the sharing and reuse of data. That's the purpose. Okay. So we want to so this is the goal why we want to do this. So it is about identification, and that should allow researchers to cite the data. But we don't want to have the citation in the title anymore because we enable citation, but we don't do the actual citation. Yeah. So that's the rationale behind it. And there is collaborative notes for the session. So if you can type in also your names and email addresses if you want to be updated on the stuff into the collaborative notes document. Any further comments? I'm looking at the chat. No. Good. Next slide, please. The goals are to create identification mechanisms, and here we're back at identification now, that allow us to identify and reference arbitrary views of data from a single record to an entire data set in a precise machine actionable manner. They allow us to identify and retrieve that data as it existed at a certain point in time, whether the database is static or dynamic. So here we point to the fact that it's addressing both issues, and are stable and consistent across different technologies and technological changes, and are applicable, and this is a pretty bold statement, to all types of data as principle. Yeah. How it's being implemented obviously will depend on the type of data that you're referring to and on the dynamics, because even simply for relational databases, there is 3 different ways how you can do it. In an integrated table, temporal table, you can create a history table. You can do a hybrid approach where you have the history table separate from the current data. And that has impact on the scalability, query processing speeds, and so on. Yeah. So how you implement it is not part of the recommendations, but the principles apply to any kind of data. And it might be trivial for some, it might be very difficult for others, but state of the data at a given point in time and some access mechanism will work for any kind of data. Next slide. Solution in a nutshell. The working group recommends solving this challenge by ensuring that data is stored in a version and timestamp manner, and that data subsets are identified by storing and assigning persistent identifiers to timestamped queries that can be re-executed against the timestamp data store. Yes.
Yeah, thanks. Yeah, maybe I'll move up front. This is the one where I got stuck when I was reading your material offline, sort of in preparation, as it were, because even though it doesn't say it explicitly, the way I read it was that you wanted each version of the entire data set to be stored. And I know that's not what you mean, but for some reason, it just, that's how I read it. And so I imagine other people might be doing that too, and might be worth clarifying if it's not.
Okay. So Yeah. I'm trying to understand the. I see the source of the misunderstanding. Yeah, because we're not doing static versioning. It's. Yeah. Exactly. Yeah. That's a good point. That's a good point. I'll add this into my notes here. Or can you type that into the meeting note? That's excellent. Thank you. Yep. We need to find a way how to rephrase it. Background and context. This document is an update to the RDA recommendations, data citation of evolving data, which was the old title. The revised document addresses questions that have arisen over the years through implementation of the specific recommendations. The changes do not affect the core requirements of the original recommendations. Rather, they clarify those recommendations. Some were combined, 1, 10, and 12. 2 implicit recommendations were made explicit, 3 and 11. While we have now while there is now fewer recommendations, none of the original content has been abolished. So it still covers the same context. That's just the background information, I guess. That's our internal versioning, basically, of the history. Next. We also clarify what we are not doing. The main point is to focus on precise identification and reference to dynamic data. They do not address how these references are credited and recognized in the scholarly systems. Okay, so that's a key message we want to send out. They address most elements of the joint declaration of data citation principles, but they do not fully address the importance principle or the credit and attribution principles. This is something that we really delegate to other groups to deal with. Yeah. We have correspondingly retitled it and to recognize that we are not addressing all aspects of data citation because that also led to confusion with some other working groups in the RDA. And we also want to emphasize that basically it also has other applications such as facilitating and tracing automated workflows. So you can now basically use a PID as an input in a processing engine, and it would automatically retrieve the data, retrieve the data and process it. And still say that they are fundamental requirements for data archiving and stewardship. Next slide, please. Background and context, the links to some of the works that we refer to, the original recommendations and the papers, and also to some related working groups, some of which we haven't found any that contradicts our recommendations, so that's fine. But we want to still make sure that they align and understand, for example, so data granularity, at what granularity is the versioning happening? And this is in our view, mostly a question of efficiency and storage trade-off. Good, next slide, please. We also point to some of the RDA research data collections recommendations, data usage metrics, and so on that are not directly linked. If there is any working group that we are missing, please let us know and we'll add it and take a look at it. If there is any cross links that we should be aware of that are not currently captured here. Because that would also be a good point to cross-check with them and see how they integrate. Good. Next slide, please. So now we go into the recommendations. And the one thing that you will notice is the phrasing, and also the capitalization is the same as in the recommendations. Versioning and timestamping, recommendation 1. If data is evolving and earlier states of the data should be reproducible, then the infrastructure must version changes to the data. And it must assign a timestamp of when a change becomes visible in the system. Okay. Because if you don't do that, you can't go back to earlier states. It's as simple as that. The timestamps can be local. That's something that we discuss later on. I guess that's fine. We also added, next slide, please. For each recommendation, there is a short rationale. If data changes in the earlier state should be reproducible, then the states must be retained. By storing with each update and change to the data at the time when this becomes visible, the state of the data can be referred to at any arbitrary point in time. Timestamps allow to refer to data as existed. Semantic labels, as used in semantic versioning, may be added as assertions on the state of data at any such point in time, but are not a suitable versioning strategy in itself. And that's because we want to identify if there is distributed processes that read data at a certain point in time. You know that from papers, they refer to a web page downloaded on the 15th of January. Unless I have a timestamp that tells me what state the data was in on the 15th of January, the version 1.1, 1.2, 1.3 itself won't help me. So I always need time in order to refer to that. And since we want to use one universal approach, the timestamp is the one thing that works everywhere. We had somebody from NASA joining the working group who said, no, if you have a satellite that circles the sun, timestamps become really nasty because relativity effects take place. But all our data centers so far on Earth, we can ignore those fluctuations for now, for the time being. Yeah, we might claim that our recommendations are not entirely future-proof once we go extra our solar system. Good. Next slide. Recommendation 2, query store facilities. The infrastructure must provide means for storing queries and the associated metadata, specifically an execution timestamp to allow re-execution against the valid state of the data source. Rational retrieving the data set requires the re-execution of the timestamp query. As the infrastructure, and this is where we're addressing that issue that you were raising before. As the data infrastructure may change over time, queries may need to be migrated to work with a new data representation. Hence, queries must be stored with the data infrastructure and not externally, because in the recommendations, in the discussion, it was deemed not very viable that, so even if you do that just for relational databases for SQL, query migration is not trivial. Imagine you insert a column with a certain name, you delete the column 2 years later, and then you reinsert it 4 years later. It's not trivial to keep that in query migrations in place. And we are trying to work around it with views. So this is where we said it should be central. Also in terms of landing pages being provided and so on and so forth. This doesn't preclude, another issue was that in many cases, the research infrastructure did not want to expose the actual query, because usually researchers work with views on the data in complex databases, not seeing the complete complexity of a third normal form data infrastructure. And then you work with views, but the views need to be translated into queries, and these are then not transparent. Next slide. Persistently identifying specific data sets. So this is now the second part of the recommendation. The first part is preparing the data infrastructure. Second part is now on the behalf of the researcher. When a user selects a subset of data, this is referred to as a query executed against the data store. If such a subset should be identifiable persistently, apply the following steps, and this is now recommendations 3 to 9. Next slide, please. R3, limit query functionality. A data infrastructure should limit the query to functions that can be deterministically recomputed across different technical infrastructure implementations. So only use query functionality that is, at least at current time, consistent across different databases, for example, and don't use anything that has numerical inaccuracies very prominently present, because then you cannot guarantee re-execution. And we had something like cosine distance measures. If you run them on different environments, Python, Java on different platforms, you get different results. And this is not something that we want, because then you can't reproduce. So really focus on select project type of functions, bounding boxes, color profile, pixel selection, whatever, but anything that can be precisely computed. If you draw a boundary around an object, don't use spline interpolation unless the spline interpolation code is part of the query, then you can re-execute. And this should be delegated to subsequent processing. Fine. Next slide, and I don't see anything on the chat yet. We then also have a clarification of what is a query. A query may be any form of data access function, such as SQL queries, selecting rows and columns in a database, a bounding box or a color profile selection, selection of files in the file system via properties, slice and dice operators in data cubes, start and end points in video streams, subgraphs in graph data structures, and so on and so forth. And we might actually shift this part of the rationale before the other one, because this is more generic on what is a query. The other one is the limitation. Next slide, please. Query PID, and this is an interesting one. A data infrastructure must assign a new PID to a query if either the query is new, semantically speaking, or if the query is an existing one, but the result set returned by it differs from the previous execution of the same query. So if the data set has changed underneath. So select star, select everything, run a year ago and run now. If the data set is static, it gets the same PID. If the data set has changed, it gets a new PID with the current execution timestamp. Otherwise, return the existing PID of the identical query that produced the identical result. Set. Yes?
If this isn't easily explained, let's move on and we'll come back. I'll come back to it in the notes. When you talk about assigning a new PID to the query, and then later in the justification, you talk about minting new PID. I think of the PIDs as being generally specified, not specifically manufactured and captured. I don't know why. It's the same question as before, but in a different context. Before I was saying, why do I have to capture the query? Now I'm saying, what do I have to capture the query? If I know what the format of the PID is, that, for example, it always has the SQL statement here, why do I have to capture every different type of SQL statement? Why can't it be a dynamic formulation of the query and not? Did the question make sense at all?
I'm trying to see whether I understand it correctly. So basically, there is two things. One, we try to avoid putting semantics in an identifier. So you can't put the query into the identifier because if 5 years later you change the data infrastructure, the query needs to be rewritten. And there is a mantra, no semantics in an identifier, and there is a good reason for that. And the other thing is you would still store the query. Whether you store it in the PID or separately, we think separately makes it clearer and allows the PID to be neutral from the technology. That plus, sometimes you need to reveal the PID publicly. Some infrastructures did not want to reveal the data structure, the internal data representations publicly, because there's some security concerns in terms of attack vectors. So the world is a complex place, and that's why we kept it separate. Yeah, we had a number of really weird inverted commas discussions and settings with different concerns, and we'll see one further of these when we come to the timestamping. Then in the rationale, well, the subsets are identified by the query and the result set. So you might have two different queries that lead to the same result set. They are still different queries, different semantics, so they get a different PID, even though the result set is the same. You might have the same query run at 2 different times, producing different result sets, also gets a new PID. And then there is an interesting sim here. Determining whether 2 queries are semantically equivalent is not trivial, and you can show that it's actually impossible in the generic case, even for SQL queries. So the worst thing that could happen is that as an infrastructure, if the queries are not created systematically, might find 2 different queries that are semantically absolutely identical, but you can't detect it. In this case, the worst thing that happens is that you assign 2 different PIDs, although the query is semantically identical, which doesn't do any harm. Okay, because there is no mantra that says a PID, there cannot be 2 identical objects that have different PIDs. So that's also not an issue. Next slide, please. So there is this discussion of whether it must or it should only, and we tend currently to go with must, but not with must only assign a new PID if it's semantically different queries, because we cannot guarantee that. So it can be tolerated if 2 PIDs are assigned to semantically identical queries. That's one of the things that is still open to discussion, but I guess we will go with that phrasing, because the other thing you cannot guarantee in any case, and it doesn't do any harm. Yeah, there is no way we can guarantee that. And should is then too generic, so we go with it must. If they are different, then it must assign one. If it thinks they are different, but they're the same, it can still assign one. It doesn't do any harm. Good. Next slide. Recommendation 5, query timestamping. If a query received a new PID, then the query must get a timestamp. So it must assign a timestamp of the query based on the time the query was executed. That's the usual thing that you want to do. Then we had data infrastructures that were worried that the execution timestamp might reveal or might be revealing privacy sensitive information of when a researcher issued the query. Apart from the fact that the timestamp doesn't need to be publicly visible because you can hide it in the metadata, but some were concerned about storing that because there's labor law issues and you're not allowed to work after time and so on. So you can also assign the timestamp of the last update to the entire data source, so the last write operation prior to the query, which increases the granularity. Or you could even go to the last update of the selection of data affected by the query. And that affected obviously includes anything that is a delete timestamp. There would be even a coarser granularity. The recommendation is to go for the simplest one, the execution one, because that carries a semantics that's meaningful. The other one is basically to disguise the actual execution timestamp. If the infrastructure needs to make that visible or store that so that it's documented and you want to avoid privacy issues. Again, we haven't seen that case in practice, but it was one of the things that came up during discussions in the working group. Any comments on that? Well, it needs to be stored because you need to understand against which state of the data it was being executed at, if you want to recreate exactly the same subset. Otherwise, there's no way to. Unless the data set is static. Yeah, and the technical implementations usually do it in another way. So they receive the non-timestamp query, add the execution timestamp in a direct rewriting, and then execute it to ensure that the racing conditions can be met. Because there is, depends on the data source. If there's locking operations in databases, you want to make sure that you run the query with a certain timestamp already upon execution to guarantee re-executability. Yes. Mm-hmm. Yeah, but that can be in the milliseconds. It's the state of the world at a given point in time. It is versioning. It's just that the versioning is continuous based on time, and it's not fixed monthly unless the data comes in monthly batches. That's fine as well, but it's a generic principle. It applies to everything, and that's why we refer to it via the timestamps, and not a sequential number, because then we know at which time it was. Yeah. 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 So I still remember the session where this came up. It was one of the early sessions where we discussed it. It was about an institutional repository. They are storing the data, they're storing the queries, and they're serving their own employees. And their employees are not allowed to work after a certain hour in the evening. And so the employer should not be aware of the employers working because there might be labor law issues. So if the institution become aware that somebody has been working at 11 o'clock at night, that might be an issue against the institution. So they refuse to take note of any activity that happened at night. And so they wouldn't want to have that happening. Again, I haven't seen this case in any real implementation yet in the many discussions that we had, but on a theoretical basis, it came up. And so that's why we documented it, to make sure that we address those issues. But I agree, it's a very specific use case. Yeah, that's easy. The last global write update is a global variable that you can always use. But we usually recommend the easiest one is the execution timestamp, because in many cases you actually want to have that information, because that's when I ran the experiment. So if you have fully automated processes that run too, you have the timestamp of when the compute happens, you have the timestamp of when the read happens. It's actually a very neat consecutive process. So that's the one that we recommend. The other ones is or in case of. Good, next slide. So there were some people who raised concerns about this last update to the selection of data affected by the query, that this might not return the correct subset. I conceptually ran through a few examples and I think it holds. But if anybody spots a logical error there, let me know. Because the data affected includes all delete timestamps as well. Because anything that's deleted before the query is being executed should hold. So I think with the best of my knowledge, it should hold. If anybody is a SQL wizard that has dived into the depth of the logics of that, let me know. Yeah. 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 Or we might to the query update and or phrase this part, this or part, or the last update a bit more generically, or any earlier timestamp that resolves into the same query, into the same results based on the last updates. And then we leave it open whether it's the last updates to the entire database or the last updates to the subset that's affected. The model itself does. Whether the infrastructure wants to support that is a different decision. No, but you could generate a PID upon execution. So if I now query data at the state as it was on the 15th of January, and that query has never been issued, and it results in a different subset than any other query at that before, it would get a PID. Well, yeah, it's a PID of a query. So when the query against which state, but that's a question whether the data source wants to support this kind of time travel querying. It's called time travel querying. So that's what I mean, the mechanism supports it, but basically what infrastructure they're supporting day-to-day research, basically. That's the core mission. But yes, I agree with it. It allows, and maybe we should highlight that as one of the benefits, this time travel querying. I agree. So you can run it against, but we didn't want to force research infrastructures to allow that. But we could add that, and I'm not sure whether I guess we have it. We have it in the recommendations now. It may further allow earlier queries. So we'll get to that point. So the time travel is there. Anything in the chat? No. Next slide, please. Consistent sorting. This is where we had some discussions because it was called stable sorting before. Now it's consistent sorting. The data infrastructure should ensure that the sorting of the elements in any data set returned is unambiguous and reproducible. Reason behind it is if you use whatever databases, you pose a query, 2 times the same query, it produces the same result set, but not necessarily in the same sequence. And even if the user sorts by whatever name alphabetically, if 2 strings have the same string sequence, they might be in arbitrary order. So we recommend that prior to applying any user-defined sort, the infrastructure applies a standardized sort, and then the user supplied sort on top of that. However, that cannot be guaranteed in all cases, or it might be very expensive to guarantee in all cases. So for graph structures. So this is why we have this as a should requirement, because we are worried that there might be cases where you can't guarantee it. That's our concern, unless somebody can tell me that this can always be guaranteed in all cases, but I don't think so. This is why we kept it as a should statement. Yeah. 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 So we keep it that way. So it should, because it makes a lot of other things easier, such as computing fixity information for checking for identity. Good. Next slide. So what we also want to add, and that's still be debated, but we add another sentence to the recommendations. If consisting sorting is not guaranteed, then the data infrastructure must be explicit about that. And that's one thing that we would like to add to the recommendation. But I think it makes sense because that also communicates very clearly that you cannot rely in the further processing on the identical sequences. So you might have some distortions there. Good. Next slide, please. Result set verification. And again, here we were discussing whether it should be a must or a should. The data infrastructure should compute fixity information, checksums, of the query result set to enable verification of the correctness of the result upon re-execution. Now, by all common sense standards, this should be a must recommendation. You must compute a fixity information so that when I re-execute it, I can compare the hash sums and see whether the results really are identical. The reason why we go for a should here is twofold. One, stable sorting. It's very hard to compute fixity information if there is no standard way of linearizing the data set. But this can be overcome because you can always linearize simply the bit sequences and confirm fixity, and you don't return it in that order. The other thing why we put this as a should is if you have a result set that's 0.5 petabyte, computing fixity information across 0.5 petabyte is costly, time and compute wise. And so there might be decisions not to do that or to do something in lieu of that. So doing whatever, the fixity information only on the rows and column headers or on a fixed pattern of sub-elements of the query, which isn't proper fixity information. It doesn't give you a guarantee of identity, but a high confidence. And this is why we're currently leaning towards a should phrasing here, but are happy to hear yep. Yep. Must provide some mechanisms for varying with reasonable confidence. Ideally, precisely. Yes, but yeah, but even if you do whatever row and column headers, you can't guarantee that the bit strings. So it is no guarantee in the strict mathematical sense. Yeah. 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 So yeah. 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 So we'll put that basically in the rationale in a bit more precise detail. Yeah. Good. Next slide, please. Query preciseness. The data infrastructure must persistently store the query and associated metadata in the query store associated with the data query and must assume responsibility for re-executing the query to reproduce the data set when required to do so. Because otherwise you can't get the data back, and that's precisely what we want to achieve. So this is a must. We are still discussing, we had, for the metadata, we had example PID, original and normalized query and so on. We might take this out and put this in the rationale because the recommendation is generic. And the rationale is the queries must be maintained with the data infrastructure so that queries can be migrated when the data infrastructure should decide to change its data representation and to have this as a central place. And also, in most cases, as I said, the data infrastructure doesn't want to release the queries to the outside world. They might shield them completely. On the landing page, you don't want to put a SQL statement or the, the spline interpolated bounding box pixel positions. That doesn't make any sense. That's just a long sequence of something. So the queries may be transparent, basically. We had in the old days, we had recommendations for 2 PIDs, one for the specific subsets of the data that points to the query, and one for the database that was being queried. So like the journal, which is evolving continuously, and then the specific paper that is taken out of the journal. we decided not to include it anymore because that's already more towards the citation principles and how do you cite and reference it. So we think this is not essential, whether you point to the database or to the data infrastructure or whatever, that's left to something else. We want to identify the subset. All the metadata, which database was queried, is obviously part of the query string anyway. Good, next slide. Automated citation text. That's the one part where we lean a bit beyond the pure identification. That's a question whether we should keep it. Data infrastructure should generate citation texts in the format prevalent in the designated community to encourage scholarly citation of the data. This is a should recommendation because we're leaning and going beyond the pure identification, but I think we want to encourage citation. And so this is a should recommendation that we want to put forward. So it should provide whatever BibTeX, EndNote, phrasing of how the data center would like the data set to be cited. And also to make it easier for the researchers. Good. People happy with keeping that? Yeah, good. Next slide, please. Now we move to the one but last section, resolving PIDs. PIDs must resolve to a human readable and machine actionable landing page that provides a mechanism for accessing the data, in brackets via query execution, and metadata. The landing page may reveal the actual query being executed, as well as the associated timestamps and other metadata, depending on client's needs, security, and privacy concerns. Okay. So the query string can be completely opaque. It's just a download button. The fact that a query is executed, in most cases, we're using queries all the time without noticing it. It was so much fun when we presented the recommendations for the first time, people said, this doesn't work. And I said, whenever you're opening a file on your computer, what you're doing is you're issuing a query against the database that's called the file system, and it's grabbing things from all over the hard disk, sorting it, reassembling it, and providing it to you. It's transparent to us. We never see the query being processed. And this is like that. Click, download, and then how it provides access to it, whether that's behind a paywall, whether that requires authentication, sensitive data that requires authorization before you are granted access. That's completely transparent. That's standard procedures. Good. Next slide. I guess here we have some discussion. And this is where I need to help from the community, basically. So in my view of the world, the PID leads to a landing page, and on the landing page, you have the access mechanisms in a machine actionable way. Somebody mentioned that actually the PID should point directly to the data, and the landing page would be a PID for the metadata. And that would be two different PIDs. Any view? So my worldview was it points to the landing page, and the landing page is basically the end credits with the metadata and the actionable link to the data, because the data might be provided in different formats. Might be downloadable as a CSV file, Excel spreadsheet, whatever. That's something that the data infrastructure needs to decide. And the PID should provide both options. But again, I'm open to suggestions here if there is anybody who's really deep into the PID world. We've got a solution.
Yeah, that's true. Everybody's deeper than they want to be. So we see the same question everywhere in DataCite and semantic things as well, DOIs. And the practice that to me seems the most robust is the one in which if you enter just the PID, you get immediate access to the primary resource. If you want to get any of the many other things, other formats, metadata, a whole collection of things, you can make additions that give you access to those to your PID. You can basically add through query, additional query string or whatever. It has the advantage of not having to understand every different machine actionable mechanism to get you to the actual data. So in the semantic world, that's important because when I have a semantic text, semantic identifier, I want my computer to be able to follow that through to the direct semantic content as a default. And then if I want to do other things, I can figure out, well, what's serving that and which alternate term I have to use. Computers aren't smart enough to figure that out yet. So pick a model and hope it's the model everybody else picks.
And what would happen if the PID points directly to the data source, but that's behind a paywall? What would be the return value? Mm-hmm. Okay. Mm-hmm. 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 Okay. So then this would mean that we would need to rephrase that recommendation slightly to be more generic, or to at least allow both options. Because here with must, we are very, very strict. It must resolve to a landing page. But basically, it should be up to the data center to decide whether it resolves to the landing page or to the direct data. Mm-hmm. 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 Mm-hmm.
In countering whatever you were saying, John, I'm still trying to think about a situation where, like you said, the data exists behind some kind of an access mechanism, right? So if you have a PID that directly points to the data, I'm not sure that you would have all of the metadata, the access metadata, being returned in response to a query.
System, so your PID is getting resolved presumably by the backend system that is responsible for providing the interface. That backend system should know what is necessary to provide. If it needs a login, it should know how to provide the login. If it needs to provide some metadata for you to do something else, sign a waiver or do something else, it should know how to do that. So it's just like right now, in our world, there are places you go and it's like you can't get to that place until you fill out metadata or sign your polite way or whatever. I think the model is the same, that the back-end system that's responsible for resolving is responsible for knowing how to solve all the issues that are associated.
So isn't that a little redundant? I mean, if you have a landing page, that serves the purpose, right?
Cases where DOIs have resolved the landing pages are all maps. So you can't follow that trail computationally very easily. Admittedly, if it's behind a firewall, computer probably have one. So.
I mean, if I mean, so I mean, if the query wants to get access to the data, mm-hmm. So what about if the PIDs must resolve to human readable machine actionable access to data and the associated metadata? And then we leave it open, whether it's the landing page or directly the data, because in my world, as I see it currently being used, and here we are basically also trying to pick up institutions where they are and move them a little step ahead. If I have any PID that points to data, it takes me to a landing page on Zenodo in most cases, or whatever. And so on. And from there, and the machine, there is a JSON interface, so you can actually programmatically access it. And there can be APIs for that. And this is what I had in mind here as being the current practice. If it violates the PID principles, then I'm very happy to get any phrasing that still allows the current practice of being acceptable, because in terms of human readability, you want to have the metadata available prima facie when you resolve a PID and see something, and not get a progress bar for a petabyte. Yeah. No, it's so big. But again, this can be handshake protocols that then say, okay, you can't download it. You need to first confirm that you really have the bandwidth to get the data. So any recommendations here in the collaborative notes are highly welcome, because we want to make sure that is not violating the principles that are being put forward by the PID activities. But we also want to make sure that it's implementable for a wide variety of data sources where sometimes there is no machine actionable access directly even. Okay, good. As I said, comment. Yep. Yep. Good. Next slide, please. Data access. And here we come to the time travel query. Data access must include the possibility to rerun the timestamp query against the accordant state of the data store. That's getting the old stuff. It should further provide the option to rerun the query against the current state of the data store, because that gives you the diff of anything, any corrections, recalibrations, and so on that have been applied. It may further offer the opportunity of retrieving a different set or re-executing the query against any arbitrary state / timestamp of the data store. So we differentiate between 3 levels. This one is a must. We want to get back to the data as it was. It would be really nice if we could also get the current version, benefiting from recalibrations and error corrections. It may further provide a diff data set. So what's the difference between now and the change set? And also any arbitrary time travel query. But institutions may decide not to offer that opportunity. We could leave everything as should, make it a bit stronger. This is the only recommendation where we have these 3-stage, it must, it should, and it may. And then the data infrastructure should verify the correctness of the re-execution using the fixity information stored with the original query execution and inform the client accordingly. Again, here we have to have a should, because the other one was not a must. Although it really, really should. But we can't put 2 reallys in front of it. That would look weird. It's highly encouraged. And that's probably something that goes then into the rational text. Mm-hmm.
Migrating to a new system.
Mm-hmm.
I could think of myself, instead of trying to, update an entire set of, queries for a given data, so we've got like 300 data sets. If I saw that there was only like 1 or 2 queries against a given data set, I might decide to just version the results of those 2 queries, stick them in the new database and say, here's what these results are now. I don't know if that's described in this access thing, and I don't know if it should be.
So what it's not in the access. What we have in the question and answer section is, can data be deleted? Can subsets be deleted? Can queries become irreproducible? And yes, of course.
Okay.
Following the policies of the institution.
Okay.
So it shouldn't just disappear. And if you decide to abandon the database and just keep the zip files to resolve, that's perfectly fine as well. It's just then not following the recommendations anymore.
Okay.
Which you're fine to do.
Right.
I mean, we're not saying any data center that doesn't apply is not a data center. But if you're following the recommendations, then this is the mechanism for the operation purposes. We want to get away from 5,000 zip files being managed.
Yeah. But I could definitely see a lot of cases where.
Yeah.
Okay.
We don't need to make the entire world converted. That's not the intention. Good. Technology migration, when data is migrated to new representation, the infrastructure must migrate the queries and associated fixed information and verify the correctness. Because otherwise you can't recreate it. And otherwise the burden over many, many years in technology migrations usually will become unbearable. Yeah, I noticed. This is the last recommendation that we wanted to discuss. The rest of the slides, I mean, I'll share them online anyway. Only have the rest of the text with the question answer. So the only slide I might want to jump to is the non-encouraged ones. Can you go further, please? Next slide. Next slide. Let's just sum up again. Benefits, they're fine. Next slide. Next slide. Non-endorsed. The infrastructure must not store redundant data experts in lieu of the present recommendations. They may still be used as an additional precaution, and we can end, retirement opportunity. So we can add that to it if you want to have the, but it's not replacing the recommendations. Yeah, that's the one. Next one is, next slide, please. Should not apply semantic versioning as a basis. Any semantic qualification should be phrased as a semantic annotation or assertion against the data source. So you have a query and then you say, this is stable release 1, this is the annual release or quarterly release that goes into the reports. Also, the reason is because the difference between a minor and a major update does not exist with data, because we don't have the non-breaking property with data. Fixing a simple typo might create different research results downstream. And the last one is the infrastructure should not apply a changelog approach, because that's what some databases do, because then in order to rerun a query, you need to hold the data infrastructure, apply a rollback, execute the query, and then roll it to the front again, which is just very, very costly and usually not viable. So a should recommendation to make it clear that this is not what we would recommend, because if it's very expensive to re-execute queries, people will not use it and it will not be offered as a service. And that's basically it. Are people happy with it? And I'll take a look at all the notes that have come, and I'm happy to enter into further discussions to make sure that we phrase it precisely, because we hope that the new version will again live for a couple of years, because we really think this is a useful approach that a lot of data infrastructures can implement. And we hope that we will see a lot more adoptions in the near future, because it really does make the life of the researchers easier. And yes, it puts the burden on the infrastructure, but that's what infrastructures are there for, to bear the burden for supporting the researchers and the research efforts that undergo and improve the quality of the research, because suddenly at least the data becomes reproducible without the researcher having to worry about it and not having to remember to upload a zip file of the data that they collected somewhere. We also have some discussions on, you don't need to assign a PID to every query. You can do a kind of shopping basket thing where the researchers run queries continuously to, narrow down the data set and then say, this is the one that I actually used. And that one then gets a PID and you've got the PhD goes to the user. And that's the one that then gets a PID, for example, and have the rest in a staging area only. And that's also in the explanatory text. And we should put that actually in the rationale also to the new PID assignment. That's an important point that I need to.
Getting walked through this, I'll just sum up by saying, for me, it was all very helpful because I was struggling to just read it and get through it. So a whole lot of very principled work, very impressed. I think the only thing that I think is desperately needed maybe is the thing that communicates to data system developers what kind of an architecture actually does this, because that's the problem I'm facing. So that's
if you can put us into contact with any of these,
I'll talk to you.
very, very happy to help. That's what we have been doing in the past few years, basically.
No, it's
And
more than that, but
we have quite some experience. Years of experience. I mean, it was always done by the infrastructures, but the dialogue is really quick running. I mean, for databases, you could say temporal tables, and you're almost done basically with that, except for very specific cases where you want to find a difference.
Yeah. Great, thank you.
Thank you very much. Thank you for all your comments and notes. We'll try our best to incorporate them. I hope you subscribe to the working group, so you will get a notification when we release the next iteration of it. Again, for open comments, and then we will submit it again to TAP for endorsement. Whether we do that before the next plenary or whether we'll wait for another feedback round at the next plenary, just to get more feedback and assistance there, is something that we still need to decide. We don't see a rush to push it through and get it stamped off very quickly. But if we feel confident that this is reasonably stable, we'll leave it at that and send it to TAP and then it goes out to community feedback anyway again. But yeah, anybody who wants to adopt it, anybody who would be interested in rolling it out within their own infrastructure, please let me know. Even if you have done it, or if you know an infrastructure, we were once informed of an infrastructure that has implemented it without knowing it. They had just done it that way because it felt natural to them. We're collecting those stories because I think it's good examples of how it can be done. And with that, I say thank you to everybody participating in presence and online. I'm looking whether there's any chat messages that have arrived since. No. Good. I hope it was useful also for the participants online. And I say thank you. Sorry for keeping you overtime. And I'll release you to coffee, and I'm still around for discussions if anybody wants to stay and keep discussing that topic. Thank you so much.